72 hours ago, observatories worldwide detected something that violates every law of physics we know. An interstellar object named 3I Atlas just performed a maneuver that should be impossible for any natural comet. And here's what they're not telling you. 3 independent research teams have gone silent after publishing their preliminary findings. The data shows Atlas executing what engineers call a controlled deceleration, something only spacecraft can do. Yet this object came from beyond our solar system, from a place where no human technology has ever reached. The numbers are undeniable. The implications are staggering. And the window to observe it is closing fast. What you're about to hear isn't speculation. It's raw data from the world's most powerful telescopes, data that's already being scrubbed from public archives. So what really happened when 3I Atlas entered our cosmic neighborhood? And why are some scientists suddenly refusing to discuss their own research? For generations, we've pointed radio dishes at distant stars, waiting for a message that never came. But what if we've been looking in the wrong direction? What if advanced civilizations don't broadcast, they build? Physical objects that can cross the void between stars, carrying information, technology, perhaps even intent across light years of empty space. The mathematics are brutal. In the 13.8 billion year history of the universe, only 3 confirmed interstellar visitors have ever crossed our threshold. Oumuamua in 2017, Borisov in 2019, and now 3I Atlas. Each arrival represents a cosmic rarity so extreme that even a single anomaly demands our full attention. Each object is a message bottle thrown across an ocean of time and distance. Unlike radio signals that fade after traveling light years, a physical artifact endures. It preserves evidence. It can be studied, measured, intercepted, and if the timing is right, if we move fast enough, it might reveal technologies that took millennia to develop. Traditional SETI assumed that contact would be instantaneous, a conversation across the stars. But what if their evidence arrives slowly, silently, disguised as natural phenomena until someone looks close enough? 3I Atlas isn't just another space rock. It's a test of whether we're ready to recognize something truly alien when it appears in our telescopes. The clock is ticking. Every hour that passes, Atlas moves deeper into the solar system, changing, evolving, potentially hiding whatever secrets brought it here. And 3 objects across human history means we can't afford to dismiss any anomaly, no matter how uncomfortable it makes us. May 7th, 2025. The TESS satellite was scanning the thick star fields near the galactic center when its sensors captured something moving. Not fast enough to trigger automatic alerts. Not bright enough to stand out against thousands of background stars. Just a faint trace archived automatically, waiting for someone to notice. For 55 days, nobody did. The object swept onward, its motion too subtle, its position too crowded. Each night, TESS recorded another frame, stacking evidence onto hard drives that would sit untouched until July. This wasn't failure. This was the universe hiding in plain sight, using the Milky Way itself as camouflage. July 1st changed everything. The Atlas survey in Chile flagged an anomaly. The object had brightened dramatically, 5 times brighter than when TESS first caught it. Suddenly, observatories worldwide pivoted. Teams began frantically searching old data. The Zwicky Transient Facility found pre-discovery images from late June. Pan-stars turned up traces from mid-June. Amateur astronomers, armed with nothing but passion and public archives, filled in gaps that professionals had missed. What emerged from this digital archaeology was stunning. A complete light curve showing unprecedented activity. An object that should have been dormant was already glowing, already defying predictions, already impossible. The discovery wasn't a single moment. It was a slow realization that something had been watching us watch the stars, hidden among them for nearly 2 months before we finally noticed. Between May 7th and June 3rd, 3I Atlas brightened by a factor of 5. Simple geometry says it should have increased maybe 1.5 times as it moved from 6.36 to 5.46 astronomical units from the sun. Instead, photometry from 3 independent surveys shows a surge that's 5-fold, steady, persistent, and completely unexplained by natural processes. Each survey cross-checked against field stars and synthetic models. The systematics, the potential errors, sit below 1/10 of a magnitude. This isn't instrumentation drift. This isn't background confusion. The light curve, reconstructed from nightly observations across multiple telescopes, draws a clear arc, rising smoothly despite threading through the densest part of the galactic bulge. At 636 astronomical units, comets don't activate. Water ice stays frozen solid. Thiesen's energy is too weak. Yet the coma is already visible. Dust measurements show expansion from 300 square kilometers in May to over 1,700 by July. The numbers hold under every scrutiny. Error bars tight enough to eliminate random scatter. Statistical confidence high enough to stake careers on. The excess light demands an explanation that fits both timing and scale. No survey, no matter how sensitive, can account for this magnitude of change using standard physics. The data, laid bare across journal preprints and observation logs, leave no ambiguity. 3I Atlas was already active, already an outlier, already impossible before it ever became official. Astronomers immediately ran through every conventional explanation. Instrumental error? Cross-checked across 3 continents. Background confusion? Corrected using synthetic photometry. Underestimated closing speed? Recalibrated against galactic bulge crowding. Each possibility tested, measured, and found wanting. The light curve holds steady. Too smooth for a fluke. Too early for normal comet behavior. That's when the whispers started. Could 3I Atlas have fired thrusters? An engineered braking maneuver to match solar system velocities would explain the persistent brightening without invoking water ice or familiar volatiles. The hypothesis lives on the fringe of respectability, but the timing fits perfectly. A controlled deceleration executed far from the sun, visible as excess light, measurable as impossible physics. If true, the object's activity becomes a signature of intent, not accident. But claiming artificial control requires extraordinary evidence, and the burden of proof is crushing. Yet with each passing day, natural explanations grow weaker. The data points in one direction. The scientific establishment looks everywhere else. And the chemistry hiding in the coma might hold the answer everyone's afraid to acknowledge. The very large telescope spectrographs, tuned to detect the faintest atomic whispers, found something impossible. Nickel lines clean and well-resolved, rising clearly above background noise. But iron, which should accompany nickel in perfect partnership, was completely absent. The team at Paranal spent weeks double-checking calibrations, rerunning corrections, cross-referencing laboratory wavelengths. The answer never changed. Nickel present, iron missing. No comet in solar system history has ever shown this ratio. In nature, iron and nickel are forged together in supernova, locked in planetesimal cores, traveling as inseparable companions. The sun's photosphere holds 18 atoms of iron for every one of nickel. Even the most metal-rich comets rarely exceed a 2.1 ratio. Atlas blows past 15.1, possibly 50.1, iron lines buried so deep they're undetectable. Dr. Sofia Cardenas and her VLT team mapped nickel transitions in both moderate and high-resolution runs. Production rates measured at 4.6 grams per second. Upper limits on iron soar robust, they force the ratio off every known chart. Every attempt to find hidden iron signals, stacking exposures, probing for faint spectral blends, came up empty. Natural mechanisms can't explain it. Nickel carbonyl, a fragile molecule that vaporizes at low temperatures, could boost nickel release. But iron carbonyl is chemically unlikely to form or survive in cometary conditions. Some theorists suggest selective sputtering during planetesimal formation. Others whisper about engineered residue, nickel-rich superalloys, the kind used in spacecraft engines and high-temperature applications, eroded by ancient thrusters, leaving their chemical signature in the coma. So far, the spectrum shows no propellant lines, no obvious fuel signatures, just nickel standing alone, iron silent, the elemental ledger impossibly unbalanced, and the search for conventional explanations growing more desperate. The trajectory data reveals an even deeper paradox. Astrometric measurements from July through August show orbital drift of just 1 to 1.5 kilometers per day, barely measurable. Yet the coma and tail stretch for hundreds of thousands of kilometers behind the nucleus. For any active comet, outgassing acts like rocket thrust. Jets of vapor push the object off course, creating measurable non-gravitational acceleration. But 3I Atlas barely moves. The path is almost purely gravitational, as if the object were solid inert rock instead of an actively venting comet. The suppression of this rocket effect stands out starkly against comparable objects. Borisov, the last interstellar visitor with strong outgassing, drifted nearly 100 kilometers per day. That's 2 orders of magnitude higher than Atlas. Even a modest tail should nudge the nucleus noticeably. But Atlas resists. The anti-tail appears in images. Visible dust jets stream into space. Surface activity is undeniable, yet the orbit remains stubbornly unaltered. Models accounting for observed mass loss and surface area predict far larger trajectory shifts. The numbers refuse to cooperate with physics. If Atlas were simply a massive ice mountain, Sheer bulk could dampen the rocket effect, something so dense that even strong jets barely move it. But photometry and surface brightness analysis put strict limits on nucleus size. It's large but not impossibly so. That leaves only one alternative: active control. Constant course corrections. A shell that absorbs or redirects thrust. No known natural mechanism can bridge the gap between what telescopes see and what orbital mechanics measure. Each astrometric update tightens the error bars. The drift stays locked just above 1 kilometer per day, far below where comet physics predicts. The contradiction isn't just mathematical, it's mechanical. In the realm of natural objects, motion follows predictable laws. Here, those rules bend without breaking. Comparing interstellar visitors reveals the pattern. Borisov behaved exactly as expected. Rich coma with cyanogen and diatomic carbon. Non-gravitational acceleration at 10^6 AU per day, translating to nearly 100 kilometers daily drift. Every vapor jet nudged the nucleus. Every outburst appeared in orbital tracking. Borisov obeyed physics perfectly. Oumuamua violated every expectation. No visible outgassing, no dust, no coma. Yet its path veered sharply with non-gravitational acceleration of 2.5 by 10^4 AU per day. That's 37,000 kilometers of drift without a single observable jet. Rotation at 3 turns per day only deepened the mystery. Too little mass for a snowball. Too much movement for solid rock. Now 3I Atlas completes the trilogy in reverse. Undeniable coma. Tail stretching hundreds of thousands of kilometers. Yet measured drift barely registers at 1 to 1.5 kilometers daily. 100 times less than Borisov. A tiny fraction of Oumuamua's shift. The rocket effect missing where it should dominate, present where it should be invisible. 3 objects, 3 impossible patterns, none fitting conventional models. The universe deals its wildest cards in opposing pairs. And somewhere in this contradictions lies a truth we're not ready to accept. The Vera Rubin Observatory stands ready in Chile, its 8.4-meter mirror prepared to sweep the southern sky every few nights. The Legacy Survey of Space and Time brings unprecedented early warning capability. Future interstellar visitors won't hide in crowded starfields unnoticed. Real-time alerts will reach professionals and amateurs simultaneously. But advanced telescopes can't catch every anomaly alone. When 3I Atlas brightened 5-fold against the galactic bulge, amateur astronomers proved essential. Armed with backyard equipment and open-source software, citizen scientists trolled through terabytes of archival data, stitching together the crucial light curve. Their rapid reporting turned scattered images into coherent timelines, catching activity that would have vanished into digital noise. Now stakes climb higher. As Atlas rounds the sun, every observation matters. Coordinated campaigns across continents, Rubin sweeps, pan-stars in Hawaii, Atlas nodes in Chile, amateur stations from Pretoria to Perth combine into a global detection network. Each observer adds precision, shrinking error bars, sharpening models. The next outburst could happen any hour. Early warnings ripple through Discord servers and Telegram groups, triggering impromptu follow-ups from telescopes large and small. The directive is simple. Eyes on the sky, track the light curve, chase every spectrum, share raw data and calibrated results. In this new era of discovery, professionals don't hold monopolies on evidence. Every alert, every image, every measurement brings us closer to recognizing the improbable. Messages written not in radio waves but in motion, chemistry, and impossible physics. The Very Large Telescope's spectroscopic data shows nickel without iron. Astrometric tracking reveals almost zero non-gravitational. Acceleration despite visible. Outgassing Borisov displayed normal cometary drift. Oumuamua showed massive trajectory change without any detectable jets. These opposing anomalies remain unexplained by current models. No evidence definitively confirms artificial control. But the physical contradictions in Atlas's behavior challenge every accepted theory. The data demands answers we're not equipped to provide using conventional astronomy alone. Our best clues may not arrive as signals, but as objects whose motion defies natural explanation. As chemistry that matches no known formation process. As brightness changes that violate geometric predictions. The search for extraterrestrial intelligence assumed we'd recognize alien technology when we saw it. But what if recognition requires abandoning assumptions built over centuries? What if the evidence has been passing through our solar system all along, disguised as comets, dismissed as natural phenomena, archived and forgotten until someone finally asks the uncomfortable questions? 3I Atlas offers a singular opportunity. A physical object from another star system, exhibiting multiple impossible characteristics, observable right now with amateur equipment. The window closes daily as it moves deeper into the solar system. Telescopes worldwide remain trained on its position. Data flows continuously into research archives and public databases, but funding pressures mount. Observation time competes with other priorities, and some research teams have quietly stopped publishing updates without explanation. This is the reality of modern astronomy. Evidence that challenges paradigms faces institutional resistance. Papers get delayed in peer review. Grant applications receive skeptical evaluations. Careers hang in the balance when conventional explanations fail. Yet the numbers don't lie. The chemistry remains impossible. The trajectory defies physics. And time runs out. In 48 hours, Atlas will be too close to the sun for optimal observation. In 2 weeks, it begins its outbound journey, fading from view. In 6 months, it returns to interstellar space, carrying whatever secrets brought it here back into the cosmic darkness. This moment right now represents humanity's best chance to gather evidence that might never repeat. The question isn't whether 3I Atlas is artificial. The question is whether we're brave enough to admit when nature stops making sense, when 3 impossible characteristics align in a single object, when the simplest explanation requires rewriting textbooks. The data exists. The telescopes remain operational. And the truth, whatever it is, hurtles through our solar system at 30 kilometers per second, daring us to look closer before it's gone forever.